Hello, I'm Sridhar Ranganathan. I'm a program manager for Azure Database for PostgreSQL at Microsoft. I've been working with relational database technologies, including Oracle and Postgres, for nearly 20 years in both technical and PM roles. I'm passionate about data protection, high availability, and business continuity aspects of databases. Today, I'm really excited to talk to you about deploying and running your mission critical applications with Azure Database for Postgres. Let me begin this talk by discussing about Postgres and why it is a popular database. I will then go over how Azure builds on top of Postgres capabilities. Then I will discuss few Postgres deployment options for your applications on Azure. And finally, end the talk with what makes Azure the best destination for Postgres. As many of you probably know, Postgres is the world's most advanced open source relational database. Why is it? The primary reason is it's open source with a large developer community, with developers and DBAs love Postgres. Second, it's over 20 years in development with proven resiliency and stability, with thousands of mission critical applications running on Postgres. And third, it has rich feature sets, right? Such as a lot of data types that you can configure, rich indexing, full text search, JSON-B support, and also extensibility. Overall, by staying true to its principle of being standard compliant and highly programmable, Postgres has really solidified its position as the most loved database. Now, Postgres is more popular than ever, right? At the forefront, Postgres has shown that it's an open source database built for every type of developer. DB engines ranked Postgres as the DBMS of the year for both 2017 and 2018. Similarly, like Stack Overflow 2019 developer survey revealed that Postgres is the most loved and wanted database. And Microsoft loves Postgres and it's committed to Postgres. As part of it, like Microsoft acquired Citus Data, a Postgres company, reaffirming its commitment and continue to release periodic updates for Citus back to the community. We are also very excited to have Postgres committers Thomas, Jeff, Andres, and David join our team. Having such core expertise in our team is helping us to get a better and deeper understanding of Postgres and also allowing us to contribute back to the community. So with all those rich set of features and capabilities, Postgres is really built for the cloud. And Azure builds on Postgres and makes it easy to deploy and run your Postgres database by adding capabilities such as security, ecosystem integration, scaling operations, high availability, automatic backups, and so on and so forth. So essentially, Azure Database for Postgres is a fully managed, intelligent, and scalable Postgres service. I show this short URL here. So if you want to know more details, please use that URL. So what you can build with Azure Postgres. So I'm going to show some examples of applications that you can deploy with Azure Postgres. First one is like using AKS, which is Azure Kubernetes Service, right? It's basically a fully managed Kubernetes service that helps deployment and management of containerized applications. So you can use or engage cloud native developers and deploy it on AKS with the flexibility and also avail the extensibility of Postgres and build modern applications. You can enable real-time operational analytics where you don't have to have many databases separately for transactions and analytics. You can converge them with Postgres. You can build geospatial data like leveraging PostGIS extension, or you can use time series. You can convert Postgres to be a time series database, and you can make just-in-time decisions based on event-driven applications. So Azure Database for Postgres, we use community version of Postgres and not a forked one. So which means that whatever applications you are creating on the database, you can pretty much port to any other location and continue to run. So how does Azure in a managed service help you building much faster and efficient applications, right? Primarily, the purpose of the managed service is to take care of the basic operations or management of database so that you can focus on your application. Right? So Azure basically ensures your database is periodically updated, automatically updated, and keeps up to date with all bug fixes and security fixes so that you can focus on your application. And it allows you to scale your resources independently, both compute and storage. It is built in compliance and security. It automatically leverage enterprise-grade security that already built in with Azure. You'll receive like security alerts with advanced threat protection. And last but not least, rest assured that you have the best in industry uncapped defense and indemnification coverage from Azure. Let's start looking into some deployment options and some use cases and some applications how you can deploy with Azure database for Postgres. Right? Let's say you want to migrate to cloud or you want to modernize your application. Right? So we recently launched a new deployment model in Azure. It's called Flexible Server. Right? So currently it is in preview. So I will go over some of the concepts of a Flexible Server and how we can deploy your application with this deployment model. So Flexible Server effectively runs your enterprise workload. Why? Because it provides you maximum control for your database. Though it's managed service and we offer optimized parameter settings and depending on what the compute tier you choose, storage size you use, you can still go and tune few things to suit your business and application. Such as like you can configure your network configuration, what clients can access and how it can access. You can tune parameters and you can define what time that periodic updates should happen, right? So essentially, like you can choose the date and time of the week, for example, and that's when like the updates happen. So you can also build resilient applications, so the zone redundant, high availability. So essentially, like you are deploying a standby database on a different zone, so to protect from zone level failures. And it's in synchronous mode, which provides zero data loss. And you can co-locate application and database in the same zone for much better performance. Right? We also optimized a lot for a simplified developer experience. For example, like it provides a simple end-to-end deployment, right? Very easy to run a command or go through UI to deploy a database. And it's a fully compatible community Postgres. It's not a forked version. And we have cost optimization, such as like a stop and start, where you can, if you're in a development environment and if you don't want to keep it running over the weekend, you can turn off on Friday, for example, and you can start it on Monday morning, right? So that way, like you are not incurring any charges for the compute. When you're deploying a flexible server, you can choose which region you want to deploy and which availability zone you want to deploy in it. So essentially, region is a separate geographical regions, and then each region have different availability zones. And you can deploy your applications, VMs, and databases like to be co-located together. So, you have optimal performance. We are going to spin up a Linux virtual machine, and we install Postgres database in it. So you currently support 11 and 12. And the storage is basically Azure premium storage for storing data and logs. That is redundant, multiple copies within the zone for resiliency and high availability. And the periodic backups are done to the zone redundant storage. So that backup is available across all the zones within the region. So you can also deploy your applications along with the database for low latency and high performance. So if you want to protect your applications from zone level failures and need the ability to fast failover, you can then choose the zone redundant high availability deployment. So when you choose that option, a standby database is provisioned on a different zone. A synchronous mode of physical replication is established, and that provides a zero data loss in the event of a failover. All application commits and writes on the primary are acknowledged only after the standby received the data and then it's persisted. So this setup basically gives you a good, high availability and faster failover capabilities. So what happens in the event of a failure, right? So let's say like a node crash or a serious networking issue or a serious storage fault on the zone, and then your database is no longer available, right? So the flexible server detects that and it fails over to the standby. The standby server which is basically a replica. It's activated and it becomes a read-write node, and your applications will connect to that, which is a new primary, and they can continue the operation there, right? So, and then a new standby is established on the previous zone that you were previously operating, right? So in this model, it gives you a much faster failover, much lower RTO, and it gives you high availability in the event of a serious fault of the primary. So from networking perspective, Flexible Server supports two modes of access. So one is using public access. So it is using public endpoint, right? It is resolvable publicly using DNS address, and you can restrict what IPs can access to it using firewall rules. And Flexible Server also allows private access using VNet integration. Servers in Azure Virtual Network can only be reached and connected through a private IP address. And you can create a separate subnet for deploying your flexible server, and you can define rules on what clients can access that. From the client connectivity perspective, we enforce CLS 1.2 and above. So let's build an application with Azure Database for Postgres. So it's a sample application. It could be a transaction application here, which uses AKS or Azure Kubernetes Service. As I mentioned, it is a managed Kubernetes cluster in Azure. You can modernize your application development practices to basically microservice and container-based approach. And on the database side, which is on the middle of your screen, you can deploy a fully managed Postgres and configured with the VNet and zone redundant high availability. And you can offload database demands by managing session state and assets caching with Azure Cache for Redis. And on the left, you can see Azure Functions, where it's a serverless infrastructure, where you can trigger alert based on key events such as user activity using Azure Functions. And on the left, you can see a notification hub, where you can push a notification directly to your users on their preferred service or medium using the service. And Azure Databricks, which is in the bottom of the screen, is an Apache Spark-based analytics platform. It's a big data tool where you can perform deeper analysis of the data. And finally, you can monitor your application performance for degradation or anomalies and auto-scale your application to changing performance requirements. Now, say if your application demands more performance and you want to scale out to hundreds of nodes and handle terabytes or petabytes of data, then you can choose Azure Database for Postgres Hyperscale Citus deployment. So as I mentioned, Microsoft acquired Postgres company last year called Citus Data. The team created the Citus extension, which is an open source that transforms Postgres into a distributed database that you can scale horizontally. Right? Citus is now available in the cloud as Hyperscale Citus. It's a built-in deployment option in Azure Database for Postgres. So Hyperscale Citus is a managed Postgres database service with data inquiries distributed across nodes to provide unlimited horizontal scalability. You're basically sharding your Postgres database across multiple nodes to give your application more memory, compute, and storage. This is the GitHub page, and visit this page to learn more about Citus extension. So what you can do with Hyperscale Citus, right? First, you can scale out horizontally to, you're no longer confined to one single node. You can scale out to hundreds of nodes. You can ingest data at a real time, sub-second response, and billions of rows, right, with the blazing performance. It's a simplified architecture, right? So both transaction analytics, you can store it on the same database. And you can stay current with Postgres innovations. Like it is based on open source extension. Postgres itself is open source. So you can leverage all your Postgres expertise to its latest innovation. So building an application with Hyperscale Citus. So previously, we deployed an application, transaction application using AKS and Flexible Server. So if you want to scale out, you basically replace the database component using Hyperscale instead of flexible server. With that, you can basically scale out horizontally, and with more performance and with more nodes. And another application example is the real-time analytics. In this, we are basically going to ingest data into Citus, and then how you can connect with other Azure services to avail more value from it. So Azure Event Hubs in the middle of the screen is a big data streaming platform and event ingestion service. You can stream millions of events per second from devices and sensors to it, and then you can build downstream pipeline to process, manipulate, and ingest your data. Ingest those millions of raw transaction events into Citus, it's per second, and which allows you to query and alert on granular events. You can do periodic incremental roll-ups directly in your database for real-time reporting and also for dashboarding for downstream applications. And you can take advantage of Azure Databricks to clean, transform, and analyze streaming data, and combine that with the structured data from operational database or data warehouse. I can provide insights to users and operators in the on current device status that you can see in the bottom of the screen. And you can push timely notifications to your users on their preferred service or medium. A few components of Azure that you can put together to have in real-time analytics with Hyperscale Citus. So moving on to real-world examples here, right? Microsoft Windows. So Microsoft Windows diagnostic metrics are displayed on real-time analytics dashboard called Release Quality View, and that is populated from Citus. So essentially, they deployed across 2 Citus clusters with 2,800 over cores with 19 terabytes of memory, right, and petabytes of data. So essentially, it is supporting about 6 million queries every day with 2 petabytes of data, and most queries are responded with less than a second. So this is critical for Microsoft Windows for mission critical shiproom decisions. And another example is ASB, which is a large bank in New Zealand. So they were having 40 minutes to onboard customers. And with Citus, they were able to cut it down to 2 minutes, which is 20 times faster. Now, customers, right, their environments are getting complex now. They have tens of hundreds of thousands of applications such as containers, VMs, databases, right? And they run on diverse infrastructure such as data centers, hosters, branch offices, and so on. And they also deploy in multi-cloud, right? And with that, they also have applications that cannot move to public cloud due to regulatory and compliance reasons. So in that situation, if you want to run Postgres in your infrastructure, because of any of those restrictions there, right? We have a new deployment option. It's called Azure Arc enabled Postgres Hyperscale, which is part of Azure Arc enabled data services. So what is Azure Arc? It's one of the 3 pillars of Azure Hybrid, along with Azure Stack and Azure IoT. Right? So Azure Arc for database data services is offered through Azure Arc, where the infrastructure is provided by the customer, and also customer takes care of the operations, while the software is provided by Microsoft. So what is Azure Arc enabled Postgres Hyperscale? Right. So it's pretty much Azure Arc makes it possible to run Azure data services on premises, at the edge, and in public clouds such as Azure, AWS, or Google Cloud. Right. So with the software provided by Azure, it is always current, right? It's automatically updated, and you can scale your infrastructure, using that same automation. Of course, you are providing the infrastructure, but the software makes it easy for scaling, and provides a unified management, a single view for on-prem and cloud using familiar tools. Azure policy is implemented, and also cloud-based billing, right? It's all you are going to enjoy all the benefits of the cloud, but in your data center or your preference. So essentially, it can run anywhere using Azure Arc. And the only requirement is it requires Kubernetes, any Kubernetes. And they have a short URL there. You can read more about Azure Arc data services. I'll switch to what's making Azure the best destination for running Postgres applications. Azure Postgres offers a variety of deployment options to choose from, starting with burstable compute to scaling to hundreds of nodes to meet your requirements. Right? So we talked about flexible server, where it gives you control, flexibility, and high availability. Hyperscale Citus, it provides a distributed database with unlimited scalability. And we have Postgres Hyperscale, Azure Arc, that runs Hyperscale on your preferred infrastructure. When you also have single server, which is fully managed PostgreSQL service. So with that various deployment option, let me go over some of the building blocks in making Azure the best destination for Postgres. Right. To start with, Postgres is the best open source database with a large community support, right, and the proven reliability and stability with rich features. Right. And then add Azure's management capabilities. It's fully managed, integrated intelligent performance, highly scalable, highly available, and then it provides maximum control. So that all with a Postgres database, and then you put that all the management capabilities on top of it. And you can add all the integration with Azure ecosystem, right? We provide integration points with, say, Active Directory, Visual Studio, Azure Data Factory, Power BI, and so on, so that you can build your application end-to-end on Azure. So all the Azure services has the identity, security, management, and compliance. It's all available in Microsoft Azure, right? And with Azure Arc, you are even extending that same capability to a non-Azure infrastructure too. So far, I covered how you deploy your mission-critical applications on various Azure Postgres deployment modes. To learn more about the latest happening in Citus, Azure Database, and even for Postgres, you can subscribe to this newsletter that I put a short URL here. And also have additional resources that you can take a look into, including that Azure service page and flexible server details. Right? There is a feedback forum and email. So where you want any questions or concerns or any requirements you may have, please feel free to post your questions to either to the forum or to the email. So with that, I conclude the session and hope you found this session useful. We are looking forward to hearing from you, and thank you for your time, and bye.